Okay, so we're going to look at a problem here with this figure. I mean, I drew it kind of small and ugly, but I wanted to give myself more room here to do this. So the problem here we're going to do here, so this is an example. They give us that VAN is equal to VAP, which is 80 volts, and then they say that IC0 is equal to 0.8 milliamps. And then we want to know open circuit voltage gain. And then we also want to know RL so voltage gain is 1/2 open circuit gain. Okay, so for part A, this is where you have to keep in mind here the difference between open circuit and loaded gains. So open circuit gain, as a side note, I will provide these formulas on the exam, but I'm not going to tell you which one's open circuit and which one's not. I'm just going to give you gain formulas. Okay? Open circuit gain, remember, is -1 over VT over 1 over VAN plus 1 over VAP. And then this is equal to -1 over 0.026 divided by 1 over 80 plus 1 over 80. And I'm going to pause the recording here just for a second so I can compute this. And when I compute it, I get -1538 as the gain. Now part B wants us to figure out RL so that loaded gain is 1/2 of the open circuit, which if I just do 1/2 of that right now, we get 769. So we want a gain of 769, -769. Now remember, our loaded gain equation is, so this is for a load, this was open, is -GM RO and parallel with RL and parallel with RO2, which I'm going to rewrite this in a second here, but let's go ahead and first figure out what GM is. GM is, of course, IC over VT, which they gave me IC of 0.8 milliamps, I believe. Yes. So we have 0.8 milliamps divided by 0.026, which gives me 30.8 milliamps per volt. Now we need to figure out RO and RO2. Now remember, for this would be the early voltage divided by my current. So this would be 80 over 0.8 milliamps. And that's going to give us a nice number, but let's just double check. This is going to give me 100 kilo ohms. And then for RO2, it's VAP over RC, which is going to be the same thing, so it's 100 kilo ohms. All right, so let's go ahead and write down what we have here then. We know that The gain is negative 769 that I'm looking for. I'm just going to get rid of the negatives right away. So I have 769 has got to equal GM 30.8 milliamps per volt. Make sure to include units. And then it's 100K in parallel with RL in parallel with 100K. And now we just solve this. Now the way I would solve this is I would just simply first write this here as, well, 769 divided by 30.8 milli. So we get 24. So there might be a weird thing here. I got a phone call right as that was coming, so there's a weird little gap here, I know, sorry about that. But the answer here, when I divided both sides by 30.8 milliamps, I get 24.96, well actually it would be 97 if I round, kilo, and that'd actually be kilo ohms, is equal to 100K in parallel with RL in parallel with 100K. And then the way I would solve this is that we have 1 over 24.97K is equal to 1 over 100K plus 1 over RL plus 1 over 100K. And then you'd have 1 over RL is equal to 1 over 24.97 plus 1 over 100 plus 1 over 100, not plus. These are minuses. Can't even solve the stupid equation. Now these are minuses, of course, and then you can get it. Now I dropped the k ohm, but I just know everything's in kilo ohms, and if we do that computation, let's see what we get here. If we do that computation, we get 1 divided by 24.97 minus 0.01 minus 0.01, and then we do the inverse of that, and we get 49.88 kilo ohms, which is approximately 50 kilo ohms. So the importance here again is once we've loaded this, notice that our gain goes down significantly, or we have to have a very large resistor in order to keep the gain up there for these loads. Now there are ways to get around this using different types of current mirrors for biasing. You know, there's other ones I had mentioned in class, like the Wilson current mirror or the Widler current mirror. The Widler current mirror is a way to, you know, make it so that when you load it, you can actually still get more gain out of it as well. So there are different types of current mirrors that can help solve some of the issues when you're loading it. But this is the only one we're going to discuss in this class.